Okay, welcome to day 6. We're going to have more about domain and range. So let's talk about interval notation. Interval notation is a notation that shows the set of all numbers between and including two endpoints. So parentheses, when we use these parentheses, that means that it is not included. So this is used when we have open dots on a graph. The other one are brackets, and those are used when they are included. And on a graph, that's when closed dots. So again, that's not included, where parentheses, open dots, brackets when they are included, and we see closed dots on the graph. Okay, so let's look at an example here. So express the following solution set in interval notation. So basically we got to see, okay, where am I going? What's the furthest left and right? Where are the bounds? Well, this arrow thing, this means that it's continuing left forever. So that means that it's going to be negative infinity. And this is how we write that. It looks like a sideways 8. So that is negative infinity. And then where does it go up to? Well, if I look here, I can see that it stops at this point right here. That's 3. And we have a closed dot there. So closed dots mean it's included, so we're going to use a bracket. When it's not included, we have open dots or an arrow showing that we can't ever touch infinity, so that's why this one has a parenthesis. So up to 3, and then we're going to use a bracket. So that's how we write that. It shows that we start at negative infinity, going left forever, and negatives are to the left, that's why it's negative infinity, up to 3, but including 3, that's why we use a bracket. Okay, I'm going to skip past this next one so that you can try that one on your own. So I'm going to move down to this next example, graph the following intervals on a number line. So this one says I'm starting at negative 3 and I'm going up to 4. So on my number line, I need to include numbers starting at negative 3 and going up to 4. So I started off by just putting numbers here on my number line, starting with negative 3 and going up to 4. And now I'm going to worry about, okay, well, what are my endpoints? Well, I have one at negative 3, and that one is included. So when it's included, I need to use a closed dot. That's where the bracket means. So I'm going to put a closed dot on negative 3. And then if I look over here, I've got 4. That one is not included, so that means that I need to use an open dot. Okay, so it can be, those are the endpoints, but then it can be anywhere in between, so I need to make sure that I cover my number line, showing that it can be anywhere in between those 2 points. Okay, so that's how we graph those. And I'm going to leave this one so you can try one on your own in class. Okay, let's move down to the next part. Okay, we're going to switch to the next page, so page 12 in your packet. Now we're going to talk about the domain and range of graphs. So the domain is the set of x values, and these are used in the relation or function. These are your input values. And then the range is your set of y values used in a relation or function, and those are also called your output values. I spoke a little bit about the vertical line test. This is a test that's used on graphs to determine if a graph is a function. If the vertical line crosses the graph more than once, it is not a function. So in this first one, anywhere I put a vertical line, it would only pass in one location on the function. So that means this is a function. It's a function because every input has a unique output, and I found that by doing the vertical line test. Now, however, when I look at the one on the right side, if I put a vertical line, we can see that this vertical line, if I put it in a couple different places, it will pass the function in more than one, in the graph, the relation, in more than one location. So that means that this one is not a function. So again, over here, this vertical line, anywhere I put it, it will only touch the blue graph in one place. That makes it a function. Over here, when I put it through, it starts off only in one place, but in the middle here, we can see that it crosses in more than one location. There's 3 different places. So that one is not a function. So it's not a function because the input values do not have unique outputs. Interval notation is extremely valuable when we report the domain and range of a graph. So the domain, again, your inputs, this is a set of x values of a relation, x comma y, and the domain is determined by reading a graph from left to right. The range, your output values, is the set of y values of a relation xy, and the range is determined by reading a graph from the bottom to the top. Okay, so we'll stop there and we'll do more of this tomorrow in class. Have a good night.